Good morning, Taimina Khan is here in TKmaths is fun. In today's video, we will solve a challenging question of kinematics, which is taken from June 14, variant 11, question 9. And you can see here my website address and my blog address. If you want to watch more videos on any of the topic of O-level and A-level maths and maths, you can visit this site. So let's begin with the question. But before we start the question, you need to recap or recall few concepts. One is distance time graph or displacement time graph. This straight line, which has this direction, shows that the speed is constant and steady. A straight horizontal line shows the speed is 0. And if you compare this line and this line, this is steeper, it means the speed is greater here, right? Similarly, in the velocity time graph or speed time graph, the gradient will give you the acceleration. And when your speed or velocity is horizontal line, it means gradient is 0 and the speed is constant. There is no acceleration. Acceleration is 0 here. And here acceleration is steeper. So important thing to remember is that the area under the curve will give you distance and gradient will give you acceleration, and horizontal line will give you 0 acceleration, right? Speed is constant. Besides that, you have to remember that if the displacement is given to you, displacement equation, and you differentiate it, you get a velocity equation. And when you differentiate velocity equation, you get an acceleration equation. In integration, because it is a reverse of differentiation, if acceleration is given to you and you integrate it, you will get a velocity equation. And if you integrate a velocity equation, you get a distance or displacement equation. When a particle is instantaneously at rest, it means v is equals to 0. Okay? And please, this is displacement. By mistake, I said distance, right? Okay. So let's begin with the question. The question is given to you here. And this is velocity time graph. You have to find the distance traveled by the particle p. It is given to you that p moving in a straight line with the velocity v at time t seconds after leaving a fixed point O. So this question is simple. We have to find the distance. We will find the area under the curve. The shape is trapezium. We just need to recall the formula for the area of trapezium. I hope all of you remember it. It is half into height into sum of parallel sides, right? Now, important thing here is you should be able to read the meaning of or the value of each box. If I see here, there are 10 boxes and it is written 10 unit. It means each one is representing 1 unit. So 1 second, 2 second, 3 second, 4 second, 5, and so on. Whereas here, if you see, this is 5 units. So 10 boxes equals to 5 units. It means 2 boxes will be equals to 1 unit. So each one is 0.5. So accordingly, you will read, if I read this point, it is 1, 2, 3, 4 boxes up. So this is 12, right? So to find the area under this, we need to find out what is this height, what is this length, and what is this length, so that we can apply in the area for trapezium formula the values. And I have already told you how to read these values. So we are just simply plugging in here the values. Now, next part of the question is saying that it is a displacement time graph and you have to transform it into velocity time graph. Now, if you remember here, we have just seen the sketch where this line on the displacement time graph shows you constant speed, constant velocity. And when distance is, on the distance time graph, the speed is, or the line is horizontal, it means 0 velocity. And again here, it has certain velocity which is moving at a constant rate. Now, what is that? If you see here, gradient formula we know, so this point is 0, 0, and this point is 6, 12. So you can apply gradient formula and you will get gradient to it means the velocity, constant rate of velocity is 2, right? Constant velocity or steady velocity is 2. Here the line is horizontal. It means the velocity is 0 and particle is stopped, right? And here again, I have this point is 25, 12, and this is 30, 17. So simply applying gradient formula, you get 1. It means the velocity, constant velocity in this phase is 1 meter per second. And we know that gradient or rate of change in this graph, in this displacement time graph, will give you velocity. So let's just sketch here. This part is showing that for 6 seconds, the velocity is 2 meter per second. So if you see here, I have drawn line here, 2 meter per second for 6 seconds. Here, if you see, the velocity is 0 from 6 seconds to 25 seconds. So I have drawn the line here on the x-axis. So you will draw it. You will not just leave it as it is. You will highlight, you will bold it. I have used different colors, but you can use just bold line here. And this is velocity equals to 1 for 5 seconds. So I have drawn horizontal line, constant velocity, right? Because that was a displacement time graph. So this is how you will sketch it. Now in this question, why I especially picked it up, because it has equation of logarithm. So you will get in kinematics three types of equations: logarithmic equation, exponential equation, trigonometric equation, and polynomial also. So we have to find the value of t for which the particle r, they're talking about a particle and the name is r. It is instantaneously at rest. So what was the time? So if you can recall, when we talk about instantaneously at rest, it means v is equals to 0, right? This is what we have seen. Now it means this displacement equation I will change into velocity equation. And how we will do that? By differentiating it. So we will differentiate it, we will get a velocity equation, and we will put v0 and solve for t. So after differentiation, 40 is 4, this will be 16 times 1 over t plus 1. Constant becomes 0 in differentiation. So now you put v0, the reason is it is instantaneously at rest. So you put your v0 and you simply solve it to get the value of t. So it is 3. Next part of the question is saying find the value of t for which the acceleration of the particle is 0.25. Now it means we need to find out the acceleration equation. So this velocity equation we will differentiate one more time, right? And I'm taking it up in the numerator. So I got a, constant becomes 0, I'm differentiating it. And this is my acceleration equation. I have to put acceleration 0.25 to get t. So I'm substituting 0.25 here. And then I will simply manipulate it to get the value of t, which is 7 seconds. So thank you very much for watching this video. In my next video, I'm solving a question of November 15 to 3 question 7. If you want to see, you can see the link of this video in the description. So please share it and with your friends, press like and subscribe button. Give your comments to improve the videos. Thank you very much. Take care. Allah Hafiz.